Hello everyone and welcome to EverlastCyber. In today's video we'll be going through some CCNA practice questions and answers. The CCNA certification, that's the Cisco Certified Network Associate certification. This is an entry-level information technology certification that is offered by Cisco. Now this certification, to obtain it, you don't need to have any IT background because it's basically an entry-level position for people that want to transition into IT and networking roles. There are various domains that are covered in this certification, such as the networking fundamentals, security fundamentals, automation, as well as IP services. So we'll be starting off with some questions and answers with in-depth explanation to each of the answers that we're selecting. Question 1. Your network has multiple switches. A user reports they can't access the network after moving their device to a new desk. The new switch port has the same configuration as the previous port. What is the most likely reason for this issue? A. The switch port is in air disabled mode. B. The device's MAC address needs to be registered on the new switch port. C. Port security is enabled on the new switch ports. D. The switch port is using a different VLAN. Now, when a user moves their device to a new desk and plugs it into a different switch port, it's likely that there will be a VLAN mismatch. But let's just go through the options from the first to the last. So for option A, if the switch port is in an air disabled mode, the switch port would be completely down, but this is a different kind of issue we have from the scenario given. In option B, in most network setups, the MAC addresses are dynamically learned and they don't need to be manually registered on new ports. For option C, while this could cause issues, that is, if the port security is enabled on the new switch ports, if the port security was causing a problem, you would likely see the switch port go into air disabled mode, but this was not mentioned in the scenario here. So, the most likely answer here is option D, that the switch port is using a different VLAN. So, even if the port has the same basic configurations, it might be assigned to a different VLAN, and this could prevent the user from accessing the network. So, with the options we have, D remains the most accurate answer, where the switch port is using a different VLAN. Question 2. Which 802.11 frame type is association response? A. Management. B. Protected frame. C. Action. D. Control. The association response frame is a type of management frame in the 802.11 Wi-Fi standard. Management frames are responsible for establishing and maintaining communication between devices like access points and client devices. So specifically, the association response is sent by the access point in response to an association request from a client attempting to join the network. Protected frames refers to frames that are encrypted and they can apply to multiple frame types, but it's not a specific frame type by itself. An action frame is another subtype of management frame and it is used for specific tasks like channel switching, but it is not related to association. Control frames are used for managing access to the wireless medium, but not for association-related tasks. So for this, our answer is option A, management. Question 3. Two switches are connected via a trunk link and hosts in VLAN 10 on both switches should communicate. However, host on one switch cannot reach host on the other switch. What is the most likely cause of this issue? A. The trunk port is misconfigured as an access point. B. The VLAN 10 is not allowed on the trunk. C. the VLAN 10 SVI is missing. D, the trunk is using the wrong encapsulation. In option A, if this were the case where the trunk port is misconfigured as an access point, the trunk wouldn't function correctly and you will have a broader communication issue and it won't be just specific to VLAN 10. For option B, this scenario arises when the VLAN 10 is not included in the list of allowed VLANs on the trunk link. So trunk links usually carry traffic for multiple VLANs, but they must be explicitly configured to allow specific VLANs to pass through. So in this case, if VLAN 10 is not allowed on the trunk, hosts on that VLAN would not be able to communicate with hosts in that VLAN 10 as well on the other switch. For option C, the VLAN 10 SVI being missing would prevent inter-VLAN routing, but this won't affect communication between hosts in the same VLAN. In option D, while incorrect encapsulation can cause issues, this is less likely compared to the more common issue of VLANs not being allowed on the trunk. So for this, our answer here is option B. VLAN 10 is not allowed on the trunk. That is why the hosts on one switch cannot reach the hosts on the other switch. Question 4. What identifies the functionality of virtual machines? A. The hypervisor communicates on layer 3 without the need for additional resources. B. Each hypervisor supports a single virtual machine and a single software switch. C. The hypervisor virtualizes physical components like CPU and memory storage. D. Virtualized servers run efficiently when physically connected to a switch that is separate from the hypervisor. In option A, hypervisors don't operate solely at layer 3, which is the network layer. Instead, they abstract and virtualize physical hardware components and network communication, and this can involve various layers of the model. In option B, the hypervisor can actually support multiple virtual machines, so option B is out of it because it says it supports a single virtual machine and a single software switch, but this is not true. In option C, a hypervisor is responsible for creating and managing virtual machines by virtualizing physical resources like memory, storage, CPU, and networking. And in option D, this is not a defining characteristic of the virtual machine functionality. So our answer here is option C. Virtualization of physical resources will allow multiple machines to run on a single physical host. That's the virtual machines, because they'll be able to share their hardware resources efficiently while maintaining isolation between the virtual machines. Question 5. A network administrator configures a static route on a router, but the route is not appearing in the routing table. What could be the reason the static route is missing from the routing table? A. The administrative distance is too high. B. The static route has a higher metric than the dynamic route. C. The exit interface is down. D. The route is not summarized. For option A, static routes typically have a low administrative distance. So unless there's a manually configured high administrative distance, this is unlikely to be the cause. So the administrative distance being too high is not the reason the static route is missing from the routing table. For option B, static routes do not use metrics like dynamic routing protocols. So this option does not apply. In option C, when a static route is configured, for it to be installed in the routing table, the exit interface must be up and operational. So if the exit interface is down, the router will not install the static route into the routing table because it will consider that route to be unreachable. For option D, summarization affects routing efficiency, but it does not affect whether a static route will appear in the routing table. So our answer here is option C. If the exit interface is down, the router will not install the static route into the routing table. Question 6. Which IPv6 address type provides communication between subnets and cannot route on the internet? A. Link local. B. Unique local. C. Multicast. D. Global unicast. Link local addresses are used for communications within the same subnet, so they are not routable beyond the local link. Unique local addresses in IP version 6 are used for communication between subnets within a private network, and they cannot be routed on the internet. Multicast addresses are used for sending data to multiple destinations simultaneously. However, they are not specific to subnet communication. While the global unicast addresses are globally unique and can be routed on the internet, so this does not apply to our question here. The answer is option B, the unique local addresses. They are similar to IP version 4 private addresses. However, they are used for internal networking within an organization. Question 7. You've configured an extended ACL to block traffic from a specific subnet, but users report they can still access resources on the blocked network. What could be the problem? A. The ACL is applied to the wrong interface. B. The ACL is configured as a standard ACL instead of an extended ACL. C. The ACL is missing a permit statement for returning traffic. D. The ACL is placed too close to the destination. When configuring an ACL, it is very important to apply it to the correct interface and direction, whether inbound or outbound, on the router or switch, because if it is applied to the wrong interface, it will not filter the traffic as intended, and users will still be able to access the resources that should have been blocked. For option B, the ACL configured as a standard ACL instead of an extended ACL. Although using a standard ACL would limit the granularity of control, the scenario here specifies that an extended ACL was configured. So option B is not applicable to our question. In option C, ACLs typically do not automatically allow return traffic unless it has been specifically configured. But this would still not cause the reported issue of users being able to access the blocked traffic. In option D, while placing the ACL closer to the destination, it might lead to inefficient filtering, but it does not result in the ACL completely failing to block traffic. So our answer here is option A. If the ACL is applied to the wrong interface or in the wrong direction, it will not filter the traffic as intended, and users will still be able to access resources that should have been blocked. Question 8. What is the benefit of using a Cisco Wireless LAN Controller? A. It eliminates the need to configure each access point individually. B. Central AP management requires more complex configurations. C. Unique SSIDs cannot use the same authentication method. D. It supports autonomous and lightweight APs. A Cisco Wireless LAN Controller centralizes the management of multiple access points within a wireless network. So this allows for a centralized configuration where the administrators can apply settings and policies to all the access points from one place. So this will eliminate the need to configure each access point individually. So if you see, this is a great benefit. For option B, centralized management simplifies configuration because changes can be made at once and applied to multiple access points. So it is not a complex exercise where you have to do more complex configurations. So option B does not apply. For option C, multiple SSIDs can use the same or different authentication method based on configuration. So option C is out. And in option D, Cisco Wireless LAN controllers are actually designed to manage lightweight access points. Autonomous access points functions independently and are not managed by a wireless LAN controller. So that is also out of the question. So for number 8, our answer is option A. The benefit of using a Cisco wireless LAN controller is that it allows for centralized configurations. So the administrators can apply settings and policies to all the access points from one place. Question 9. Two routers running OSPF are directly connected, but they are not forming an OSPF neighbor relationship. What could be the cause? A. The OSPF timers are mismatched. B. The routers are in different areas. C. The router IDs are the same. D. The link is using a different network type. While mismatched OSPF timers can prevent neighbor adjacency, it is not common. It is less common than router ID conflicts. So, in most implementations, the timers need to match, but they are typically correct unless manually configured incorrectly. In option B, OSPF routers can form neighbor relationships even if they are in different areas, as long as they are directly connected and the area configurations are correct for each side of the link. In option C, the OSPF routers must have unique router IDs in order to form a neighbor relationship. So if two routers have the same router ID, they would not form an OSPF neighbor relationship because the OSPF requires that each of the routers will have a unique identifier. In option D, different OSPF network types can affect the OSPF behavior, but this will generally cause specific adjacencies to behave differently rather than outrightly preventing the formation of a neighbor relationship. So, in a case where two routers running the OSPF are not forming the OSPF neighbor relationship, it could be that the router IDs are the same. Question 10. What are the two differences between optical fiber cabling and copper cabling? For this question, we'll be choosing two answers. A. A BNC connector is used for fiber connections. B. The glass core component is encased in a cladding. C. The data can pass through the cladding. D. Light is transmitted through the core of the fiber. E. Fiber connects to physical interfaces using RJ45 connections. Now, in this question, we're looking for the difference between the optic fiber cabling and the copper cabling. So for this, we'll be going with options B and D. In optic fiber cable, the glass core is surrounded by cladding, and this reflects light back into the core to maintain signal integrity. Also, optic fiber cables use light to transmit data, and the light travels through the core of the fiber cable, allowing for high speed and long distance communication. So that's the basic reason, that's the basic difference between the optical fiber cable and the copper cabling. Question 11. You have set up a new DHCP server, but clients on the network are not receiving IP addresses. What could be the issue? A. The DHCP server is configured with a wrong default gateway. B. The DHCP scope is not activated. C. The DHCP lease time is too short. D. The DHCP server is configured with a duplicate IP address. In option A, the DHCP server being configured with a wrong default gateway would not prevent clients from receiving their IP addresses. It will only affect their ability to communicate outside their local network after they don't receive an IP address. In option B, if the DHCP scope is not activated, the server will not lease out IP addresses to clients, even if the configuration is correct. In option C, a short lease time could lead to more frequent renewals, but it won't prevent the clients from receiving an IP address initially. While in option D, while this could cause issues with network connectivity or client communication, it won't prevent the clients from receiving an IP address as long as the server scope is active. So a likely cause of clients on the network not receiving IP addresses is option B. The DHCP scope is not activated. Without an active scope, the DHCP server has no range of IP addresses to offer to the clients. Question 12. A device detects two stations transmitting frames at the same time. This condition occurs after the first 64 bytes of the frame is received. Which interface counter increments? A. Runs. B. Collision. C. Late collision. D. CRC. A runt is a frame that is shorter than the minimum frame size, but it does not relate to collision detection. A standard collision is detected within the first 64 bytes of transmission, but the scenario that we have here describes what happens after the 64 byte threshold. So this would likely make it a late collision. Let's see what it says. A late collision occurs when a collision is detected after the first 64 bytes of a frame have been transmitted. So this is outside the normal collision window, which should happen within the first 64 bytes of transmission in an Ethernet network. In option D, the CRC or cyclic redundancy check counter increments when a frame has a corrupted checksum. This would indicate a transmission error, but it does not relate to collisions. So our answer here is option C. Late collisions indicates that there is a problem within the network configuration, maybe like the cable length exceeding the maximum allowed for Ethernet. Question 13. Your branch office is experiencing intermittent WAN connectivity issues, and you notice high latency between routers at both ends of the WAN link. What could be causing the high latency? A. The router has an incorrect routing table. B. The bandwidth on the WAN link is insufficient. C. The router interfaces have mismatched NTU settings. D. A routing loop is present. An incorrect routing table would likely cause incorrect or failed routing rather than latency. Latency is more related to the network congestion or link quality. Insufficient bandwidth can cause network congestion, leading to high latency, packet drops, and intermittent connectivity issues. In option C, a mismatched NTU settings could cause fragmentation issues or dropped packets, but they don't result in high latency unless the fragmentation process becomes problematic. A routing loop would cause packets to endlessly circulate between routers, leading to network failure rather than high latency. So our answer here is option B. When the available bandwidth is not enough to handle the data being transmitted, delays can occur, especially during the peak usage times, and this causes a network congestion leading to high latency, packet drops, and intermittent connectivity issues. Question 14. Which WAN access technology is preferred for a small office home office architecture? A. Broadband cable access. B. Frame relay packet switching. C. Dedicated point-to-point list line. D. Integrated services digital network switching. For this, we'll be going with option A. A broadband cable access is preferred for a SOHO architecture because it provides high-speed internet access at a relatively low cost. It also provides sufficient bandwidth for the typical SOHO need, such as web browsing, email, and small-scale data transfers. So this is the most preferable network for a small office, home office architecture. Question 15. You want to configure a Cisco router to send log messages of level 4 and higher to a remote syslog server. Which command would you use to configure the router? A. Login trap debugging. B. Login trap informational. C. Login trap warning. D. Login trap errors. A login trap debugging command would send all log messages from level 7 and higher, and this usually includes everything, but the scenario we have, it mentions a level 4. Login trap information now sends log messages from level 6 and higher, and it might include less severe messages than, a level 4. So that's not what we're looking for. The login trap warning command will configure the router to send syslog messages of level 4 warnings and higher to the remote syslog server, while the login trap errors will only send log messages of level 3 and higher, and it will exclude all level 4 messages. So the command we're going with is option C. The login trap warning will configure the router to send the syslog messages of level 4 warnings and higher to the remote syslog server. Question 16. What is the binary pattern of unique IP version 6 unique local address? A. 000000000, B. 11111100, C. 11111111, D. 11111101. For this, we'll be going with option D. The unique local address in IP version 6 has a specific binary prefix of FD in hexadecimal or 11111110. So the full 8-bit binary pattern for the prefix is 11111101, and this designates a unique local address. So that's our answer for question 16. That's the binary pattern of a unique IP version 6 local address. Question 17. What is the primary function of a layer 3 device? A. To transmit wireless traffic between hosts. B. To analyze traffic and drop unauthorized traffic from the internet. C. To forward traffic within the same broadcast domain. D. To pass traffic between different networks. In option A, this is the function of a wireless access point, transmitting wireless traffic between hosts. This is not a function of a layer 3 device. In option B, the function here describes a firewall, and this can operate at different levels, so it is not specific to a layer 3 device. In option C, forwarding traffic within the same broadcast domain is a layer 2 function performed by switches, so that's not our answer. While in option D, a layer 3 device like a router operates at the network layer of the OSI model, and its primary function is to forward packets between different networks by determining the best path for the data based on IP addressing. So the primary function of a layer 3 device is to forward packets between the different networks by determining the best path for the data based on the IP addressing. This allows communication between devices on separate networks. Question 18. What are the two functions of a layer 2 switch? In this, we'll be choosing two. A. Acts as a central point for association and authentication servers. B. Selects the best routes between networks on a WAN. C. Moves packets within a VLAN. D. Moves packets between different VLANs. E. Makes forwarding decisions based on the MAC address of a packet. For this, we'll be going with options C and E. A layer 2 switch moves traffic within the same VLAN by using their MAC addresses to forward the frames. It also makes forwarding decisions by examining the destination MAC address in the frame and sending it out to the appropriate switch port. So these are the two functions of a layer 2 switch. Question 19. Under which condition is TCP preferred over UDP? A. UDP is used when low latency is optimal and TCP is used when latency is tolerable. B. TCP is used when dropped data is more acceptable and UDP is used when data is accepted out of order. C. TCP is used when data reliability is critical and UDP is used when missing packets are acceptable. D. UDP is used when data is highly interactive and TCP is used when data is time sensitive. For this, we'll be going with option C. TCP is a connection-oriented protocol that ensures reliable data transmission. So it uses mechanisms like error checking, acknowledgement, and retransmission of lost packets, and this makes it ideal, especially where data reliability is critical. UDP is a connectionless protocol that does not provide reliability, error checking, or ordering. However, it is used in applications where some data loss is acceptable, but low latency and speed are crucial. So UDP is usually used in online gaming, voice and video communication, as well as live streaming, while TCP is used where data reliability is critical, like in file transfers, emails, and web browsing. So this is a case where TCP is preferred over UDP. Question 20. What is a characteristic of cloud-based network topology? A. On-site network services are provided with physical Layer 2 and Layer 3 components. B. Wireless connections provide the sole access method to services. C. Physical workstations are configured to share resources. D. Services are provided by a public, private, or hybrid deployments. For this, we'll be going with option D. In a cloud-based network topology, services and resources are delivered over the internet or on a dedicated network, and the underlying infrastructure is classified as public cloud, private cloud, and hybrid cloud. In public cloud, services are provided by a third-party provider over the internet and shared among multiple tenants. In a private cloud, the infrastructure is dedicated to a single organization, and it is either managed internally or by a third party. Hybrid cloud combines both public and private cloud infrastructures, and it allows for greater flexibility in resource management. So that's the major characteristic of a cloud-based network topology. You have the option of using either a private cloud, a public cloud, or a hybrid cloud deployment. This brings us to the end of the questions and answers video for the CCNA certification exam. Don't forget to like, comment, and share, and also hit the subscribe button so that you'll be notified when our next informative video will drop. Thank you for watching, and I'll see you in the next video.